Hello and welcome to my YouTube channel Chemistry Basics. Here we are going to learn some basic concepts related to chemistry. Now today we are going to learn some thermodynamic basics, that is intensive and extensive properties of system and also state. See, there are four glasses filled with water. I am asking this boy that which glass has highest amount of water. So he's going to find the answer, and then he answered correctly that this fourth number of glass has highest amount of water. Very good, very nice. Now I'm asking him the second question, that which glass has highest temperature. So it is not easy to answer. So he is confused because temperature cannot be measured by just observing the substances. From that basis, whether particular properties depends upon the amount of matter or they are not depend upon the amount of matter, these properties of system can be classified in a two types, that is intensive and extensive properties. So let us see what is intensive and extensive properties. Intensive property means the properties of the system which are independent on the amount of matter present in the system, which are not depend on the amount of matter present in the system. It is independent, means just merely observing the substances, merely observing the system, we cannot answer about that properties, value of that properties, we cannot guess the characteristic of that property. So these properties are intensive properties. These properties independent on the amount of matter present in the system. So they are not additive. Example of intensive properties are temperature, pressure, density. These all are intensive properties. Means you have taken a glass of water having 25 degrees Celsius temperature, another glass of water having 25 degrees Celsius, and if you mix two glasses, then temperature is not going to be 50 degrees Celsius. It is 25 degrees Celsius. Means intensive properties are not additive properties. They are independent of amount of matter. These properties are intensive properties. Another type of properties are extensive properties. These are the properties of system which are depend on the amount of matter present in the system. By just observing the amount of matter which is higher or lower, we can guess the characteristic of that particular system. So these type of properties are known as extensive properties. The properties which are dependent on the amount of matter or mass present in the system. These properties are mass, volume, total energy. All these properties are extensive properties. These properties are additive. Additive means if you have taken 5 ml of water in one glass and 5 ml of water in another glass, if you mix both water, then total volume becomes 10 ml. So these properties are additive properties. What you have to remember is intensive properties that are independent on the amount of matter present in the system, and extensive properties which are depends upon the amount of matter present in the system. These are two properties of system. One is intensive and another is extensive. Now let us move to the next topic, that is state function and path function. So see, there are two boys and one trophy is there. One of them is thinking about, I need to choose the right path to reach there, because there are so many paths and he needs to choose the shortest path to reach there. And if he chooses the right path, he can win that trophy. See, both are moving and one boy move with the right path and he wants the trophy. That is depend upon the path chosen to reach that particular position. So on that basis, the thermodynamic functions can be classified on a two type, that is state functions and path functions. So now we are going to study what is thermodynamic state function. A state function of a system is defined as the property of a system that on the initial and final state of the system and is independent of the path by which the change is carried out. This function is only depends upon the initial and final state of the system. What is now and then, that function is depend on only that condition. So these functions are known as thermodynamic state functions. Internal energy, enthalpy, entropy, all functions are thermodynamic state functions. Let us see the example. Say if we want to, this system is at initial stage which is at 25 degrees Celsius. After the lot of conversion, this final product is formed whose temperature is 30 degrees Celsius. Now, if you choose different paths to reach that system, if you choose the path A to reach that system, temperature of at initial stage is 25 degrees Celsius and at the final stage it is 30 degrees Celsius. So, what is the temperature difference? Delta T is 5 degrees Celsius. Now, if you have chosen another path to reach there, it is quite longer path. Path B, we said it. Now, but still, the temperature at the initial stage, it is 25 degrees Celsius and at the final stage, it is 30 degrees Celsius. Then the temperature difference is still 5 degrees Celsius. Means that is not depend upon the path by which the changes is carried out. It is only depend upon the what is initial temperature and the final temperature. Now, if you have chosen this another path, that is path C, which is again the longer path, but still the temperature of the initial system is 25 degrees Celsius and that of final system is 30 degrees Celsius. So, the temperature difference is 5 degrees Celsius because it is only depend upon the initial state and final state of the system and it is independent of the path by which that system acquire that particular change. So, this type of changes, these type of functions are known as thermodynamic state functions. Now see what is thermodynamic path function. As we saw in state functions, it is depends upon initial and final state of the system. But in case of path function, these are the properties of system whose values depends upon the path followed by the system to reach to the final state from the initial state. So path functions are the thermodynamic functions which are depends upon the path followed by the system. It is depends upon the path to reach final state from its initial state. These are thermodynamic path functions. Two most common examples of path functions are heat and work. Heat and work are these two functions which are path functions. See, if you have chosen path A to reach from initial point to the final point, so from reactant to product, work done is different. If you have chosen path B, naturally this is a longer path. So need more work to reach there. If there is work done is more than the path 1. Now if you have chosen another path which is again the longer path, then in that case also the work done is more than that of path A and path B. This work is depends upon the path by which that changes are carried out. Path you have chosen to reach the particular position, that properties are depends upon that path. So these properties are called path functions. State functions depends only upon the initial and final state of the system and independent of the path, but path functions depend upon the path by which the changes are carried out. It is independent of initial and final state of the system. These two functions are thermodynamic functions, that is state functions and path functions. Thank you for now.